Piling on the water on one of the largest lakes in the Netherlands, the project for the Fryslân wind farm was carried out by Van Oord. The piling of the 89 foundation piles was done using rented equipment from IHC Sikkim. Special TV is a TV channel with video reports about special transport, heavy lifting, special equipment, and trucks.
Piling on the water on one of the largest lakes in the Netherlands. The project for the Fryslân wind farm was carried out by Van Oord Marine Ingenuity. The IJsselmeer has a surface area of 1,133 square kilometers and an average depth of 4.4 meters. It was created after the completion of the STV in 1932. The construction of the Sarens installation platform, on which the equipment of Van Oord, IHC was also rigged and mounted. It took place on a closed quay near Lelystad, the Netherlands. The piling of the 89 foundation piles, monopiles, was done using rented equipment from IHC Sikkim, amongst others. The S1400 hammer that was assembled on the installation platform weighed 310 tons. It has a diameter of 5.38 meters and a height of 19.12 meters. IHC Sikkim developed the entire hammer, and they rent it out to contractors. It has completed many projects over the past 10 years. With 20 years of experience, Van Oord already has an impressive track record in the construction of offshore wind farms. Even heavier versions of this hammer exist, but they are used for foundation piles with larger diameters, lengths, and heavier soil conditions than in this project. A lot of engineering work was carried out in preparation for this project. The foundation piles were specially developed for this project, as was the Sarens installation platform. The documents and engineering work were checked extensively. And had to be approved by marine warranty, insurance, before the parts could be ordered and the construction could begin. The hydraulic hammer uses a combination of biodegradable oil and gas pressure. A compressed air cylinder is situated just above the ram weight. The ram weight falls by opening a valve, and the air pressure then accelerates this strike. The ram weight falls onto the heavy ram plate that transfers the force to the pile. Surveyors checked the pile depth using lasers and a total station. And the depth was then determined by the software of the piling rig. The Isselmeer's soil condition was thoroughly examined beforehand and forms the basis for the design of the foundation piles. First of all, a foundation pile must keep the wind turbine in place for at least 25 years without subsiding. Also, the design of the piles had to be so strong that they would not be deformed or damaged during the driving process. The force applied to the foundation piles. The energy can be set and limited at a maximum total energy of 1,400 kilojoules to drive the pile into the ground to the required depth. In total, a maximum of 2,250 megajoules of energy may be used to prevent metal fatigue. Depending on the soil conditions, the energy for pile driving is determined in advance. A predetermined energy value is used for the first strike to see how deep the pile sinks. The energy can be increased or decreased based on the distance the pile sinks during the driving process. The hoisting cable was not loosened during pile driving, but is not tensioned between the hammer and the crane's hoisting block. By not tensioning the hoisting straps, they can gradually absorb so-called pile runs, preventing major shocks to the crane. Pile runs equals sinking of the pile during pile driving through its own weight. For example, when the pile goes through a soft layer of soil. The pontoon construction is about 62 meters long, 53 meters wide and 3.5 meters deep. The crane mounted on the pontoon construction is a 1,250-ton class Terex PC 6800. With a 68-meter main boom and a 360-ton counterweight truck. This crane was chosen because it can be used for lifting and piling the monopiles, as well as mounting the wind turbines. The pontoon construction is stabilized with 4 hydraulic spud poles on the bottom of the IJsselmeer. The poles are each 38.5 meters long with a diameter of 48 inches. The spud poles are operated and monitored from the control room on the platform using sensors and cameras. Meanwhile, engineers from Van Oord had already started developing new offshore wind farm projects. One in the North Sea and one on a lake in America.